Welcome to another day on the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability, and we will go over them in a moment. The question in number 1 asks, what is a polyatomic ion? Well, a polyatomic ion is a group of atoms that are joined together covalently, and they have an overall charge. Now, covalently means that they're sharing electrons. Like when we cooperate, we're sharing our efforts. So covalent bond, they are sharing electrons. The elements are held together by sharing those electrons, and they have an overall charge. This is a very important concept for you to understand. And I think probably by now you've noticed that some of those warm-up questions are on the assessments, so you might pay close attention to those. Number 2, we are going, first of all, from the name to the formula. A good habit in the beginning to do this is to say, first of all, is magnesium an alkali metal? No. Is it an alkaline earth metal? Yes. So I do not need a Roman numeral. It is always +2. So I will write the +2 above the magnesium. Phosphate is a polyatomic ion. PO4 with a -3 charge, and it is -3. The common multiple between 2 and 3 is 6. So I need 3 magnesiums and 2 phosphates. And when we have more than one polyatomic ion, I have to put them separate in parentheses and put the number of them on the outside. Otherwise, that'd look like 42. So I have to make sure that they look, I can see that whole unit. So this number is multiplied by 3, this number by 2, and +6 and -6 is 0. And compounds must be 0. In the second case, I'm given a Roman numeral because tin is not one of the alkali metals or the alkaline earth metals or one of those silly 6 that is always the same. So I have to have a Roman numeral so I know what its charge is, and it is +4. This Roman numeral is the charge on the first element, and it is not the number of atoms, which is a common mistake for students to make. Phosphate is -3. The common multiple between 4 and 3 is 12. So I need 3 tens and 4 phosphates, so that I get +12 and -12 to be equal to 0. In C, again, I'm given a Roman numeral, and that tells me that sulfur is +6. Oxygen is -2. The common multiple, the lowest common multiple between 6 and 2 is 6. So all I have to do is multiply the oxygen by 3, and I get +6 and -6 to be 0. Now, it is important to notice that this compound is not a polyatomic ion. If it were a polyatomic ion, it would have to show its charge, and it does not. So it is a compound. Now, a little hint for you. Phosphate was -3. Well, so is phosphorus and phosphite. Sulfur has a -2 charge, and so is sulfate and sulfite. Sometimes we can look at the atomic number of an element. For example, chromate. Well, chromium is atomic number 24, so it will have a positive even number charge. They're always going to be positive, but it will have an even number charge if it has an even atomic number. Now, chromate is -2. There are 2 of them, and that gives me a -4. What I'm looking for is what is the charge of the lead, because lead is not in the first column, nor is it in the second column, nor is it one of the silly 6, so it must have a Roman numeral. If you do not have a Roman numeral, it is incorrect. And these questions on the assessment are either 1 or 2 points, and you either get it or you don't get it. So you need to know when we need Roman numerals. So this would be lead, Roman numeral 2, 4, chromate. Lead, Roman numeral 4, chromate. Now, E is a nonmetal with a nonmetal. So with that situation, we could use the prefixes. We could call this dinitrogen monoxide, where we use the Greek prefixes to demonstrate the number of atoms. Mono, di, tri, tetra, penta, hexa, hepta, nona, deca are our prefixes. But I won't give it to you in that form. So you're going to have to know how to do it with Roman numerals. So we go to the negative position. Oxygen is -2. There are 2 nitrogens. And compounds must be equal to 0. So in this case, nitrogen is +1. So we call it nitrogen, Roman numeral 1, oxide. It must have a Roman numeral 1. It is not understood, as in many math situations, we have to have this Roman numeral. No Roman numeral, no credit. So please put the Roman numerals all the time. Now we could also call this dinitrogen pentaoxide. That would be fine, and I would accept that for full credit. However, when I give it to you, I won't give it to you in that form. So oxygen is -2. There are 5 of them. That gives me a -10 on the oxygen. Compounds are 0. There are 2 nitrogens. Nitrogen is +5. So it's nitrogen, Roman numeral 5, oxide. And that's how we do those problems. Last night's homework probably was a very large challenge for you. But I wanted you to get trying, because that's how we learn, is by trying. And I will go over to last night's homework with you this time. In the beginning, we are to put the symbols into words. Number 1 is potassium bicarbonate or potassium hydrogen carbonate. And this illustrates that we have a polyatomic ion here that we need to recognize. I suggest that you learn a couple of them a night and don't pile them up until right before the quiz. Mercury is not in the first column, nor the second column, nor is it one of the silly 6. So it must have a Roman numeral. Chlorine, the negative position, it follows its periodic trend. It's -1. There are 2 of them. That gives me a -2. Compounds must be 0, so mercury must be +2. So this is mercury, Roman numeral 2, chloride. Nickel is also one that changes, so I must have a Roman numeral. Acetate, this is a polyatomic ion that I need to be able to recognize. It has a -1 charge. There are 2 of them. That gives me a -2. Therefore, nickel is +2. So it's nickel, Roman numeral 2, acetate. Calcium is an alkaline earth metal, so it's always +2. So this is just calcium sulfide. Sodium is always +1. So this is sodium nitrite. Mercury again changes, so I have to find what its charge is. Nitrate is -1. There are 2 of them. That gives me a -2, and compounds must be 0. There are 2 mercuries, so each mercury is +1. So it's mercury, Roman numeral 1, nitrate. Magnesium phosphate. We had this one in the warm-up, so you might go back through the warm-up and see how we did that one. Silver carbonate. Silver is one of the silly 6. It's always +1. Silver carbonate. Now, you could have silver Roman numeral 1 carbonate. That would be fine. It's not necessary, as long as you have the correct Roman numeral. Any other Roman numeral would be incorrect. Barium dichromate. Notice we have 2 chromiums here, so there are dichromate. Lead is not one of the ones that is always the same, so we look at the negative position. Bromine is -1 times 2 is -2. Compounds are 0, therefore lead must be +2. lead, Roman numeral 2, bromide. Now in this case, SO3 is not a polyatomic ion, it is a compound. Oxygen is -2. There are 3 of them. That gives me a -6. Sulfur must be +6. So it's sulfur, Roman numeral 6, oxide. Now I could also call it sulfur trioxide. That would be fine and I would accept that. But I'm going to give you sulfur 6 oxide. Bromine is -1. Times 3 is -3. Phosphorus is +3. Phosphorus, Roman numeral 3, bromide, or phosphorus tribromide. Oxygen is -2. Therefore, lead must be +2. Lead, Roman numeral 2, oxide. Now, we know this one is carbon dioxide, but I'm not going to give it to you that easy. Oxygen is -2. Times 2 is -4. Compounds are 0, so carbon must be +4. Carbon, Roman numeral 4, oxide. And the last one here we also had in the warm-up, and oxygen is -2. Times 5 is -10. There are 2 nitrogens, and we always find the charge for a single atom, and compounds are 0. Therefore, nitrogen is +5. Nitrogen, Roman numeral 5, oxide. That's how you do the first section. Now we're going in reverse. It's a helpful tactic to add +2 and chlorine is -1. Then I know how to get my multiple. 2 and 1, the common multiple is 2. Barium is already 2, so I need 2 chlorines. I must multiply this -1 by 2 to get -2 and +2 to be equal to 0. Magnesium is +2. Sulfate is a polyatomic ion that is -2. So it's just MgSO4. Zinc is always, always, always +2. Notice there was no Roman numeral here, so I need to know that zinc is always +2. Carbonate is a polyatomic ion with a -2 charge. So it's just ZnCO3. Now aluminum is always +3 and sulfur is -2. The common multiple between 3 and 2 is 6. So I must have 2 aluminums and 3 sulfurs to get to 0. This Roman numeral is telling me that lead is +2. Phosphate is -3. The common multiple is 6. So I must multiply the lead by 3 and the phosphate by 2. +6 and -6 is 0. Chromium is +3. That is what the Roman numeral is telling me. Fluorine is -1, so it's CrF3. Potassium is +1. Bisulfate is -1. That's the first one that we had on the worksheet on the top. Did you notice that? That was good. Mercury is +2. Chlorine is -1. Common multiple is 2. HgCl2. Lead is +2. Chromate is -2. PbRO4. Mercury is +1. Nitrate is -1. HgNO3. Aluminum is always +3, and hydroxide is -1. It is a polyatomic ion. Al, and the hydroxide must be in parentheses to show that there are 3 of them because we have 3 oxygens as well as 3 hydrogens. So I could not put this because that would only be 3 hydrogens and not 3 oxygens as well. So this we do not do. That's the second part. Now we'll do the underlined elements. In this section, we're finding the oxidation number of the underlined element. Now, we've been doing this all along, so it's really not a whole lot new. When we're looking for iron, Oxygen is -2. We want to know iron. Compounds are 0, so iron is +2. Oxygen is -2 times 3 is -6. There are 2 irons, so iron is +3. Same situation here, only now we have chromium. Oxygen is -2. Chromium must be +2. Oxygen is -2 times 3 is -6. There are 2 chromiums and compounds must be 0. This chromium is +3. Now in this case, I would like to talk to you a little bit special on this. I'm going to pull the polyatomic ion out of the compound because it's the same if I look at it in the compound or out of the compound, but the numbers are much smaller if I look at it out of the compound. So I know that dichromate has a -2 charge. And in this case, I am going to set the equation equal to its overall charge. Oxygen is -2 times 7 is -14. There are 2 chromiums, so each chromium is +6. 2x equals 12, x equals +6. And we like to see those positives, and that's how we write it. Same thing here. I'm going to take the chromate out of the compound. I'm going to set my equation equal to -2, -2 for the oxygen times 4 is -8. There's only 1 chromium in this case, and it is +6. The last one you have is tin, and chlorine is -1. There are 4 of them. That gives me a -4. Compounds are 0, and therefore tin must be +4. So I hope that helped you to give some idea of how we name compounds and get the formulas back and forth. And your facilitator has all the answers to all of these worksheets. I will not be spending every day going over your homework with you because you should be starting to understand this, and you can always go back and watch the video again to get that final information. You also have handouts that go over the rules for naming compounds, the polyatomic ions. So you do have information that you can use to find out how to do this. And it was fun today. I enjoyed it, and I look forward to seeing you tomorrow. Bye.